Hello, good afternoon, and welcome to this ETIPWind online workshop here, how innovation can deliver 450 gigawatt of offshore wind. My name is Adrian Timbur, and I'm the chair of the executive committee of ETIPWind. I'm very pleased to see so many of you taking part of this workshop today, and I will walk you through a few housekeeping details on how do we plan to run this in this afternoon. First of all, I hope you all are familiar with the tool. You got the instructions how to use it, and you got familiar with the menus that you have at your hands for questions that can be placed to the panelists that we have later on today. Please make sure all of you are muted, such that we have a proper conversation here with the panelists, and then for the time of Q&A, then we will take some of the questions from the audience up there. Mind your safety. We know this is online. However, people tend to do many things in parallel. So if you are driving, better stop, to pull over, and pay attention to the webinar here. If you're doing something else, make sure you're not watching the screen and step on the stairs or other stuff that it might injure you. So full attention is required. So for those of you in the audience that don't know what ETIPWind is, let me do an introduction here on about the ETIPs themselves and how ETIP is advising the European Commission on the Strategic Energy and Technology Plan. Right. There are two mechanisms for this influence, and one are the ETIPs, which you see on the left side of the screen here. 9 of them, which are industry-led and usually are very sector-oriented ETIPs, like ETIPWind here. It is for the wind sector, and we have 2 cross ETIPs, one on renewable heating and cooling, and the other one for system integration. In parallel with that, then we have the entire research community advising also European Commission on technologies, systems, and materials to be used in various products and solutions we are deploying within our technology landscape. But the overall goal for both organizations here, it is to drive innovation. It is to develop knowledge, to transfer the knowledge, and keep European competitiveness as much as possible in any of the defined key sectors here. At the same time, all the work that ETIP, and I'm speaking on behalf of ETIPWind here now, all the work that we are doing at ETIPWind, it is documented in a so-called research and innovation agenda. This research and innovation agenda comprises roadmaps for action for the EU and the associated, or at national level, so the associated countries members. So that's about ETIP. So let's look, why are we here today? And basically we see that wind is a cornerstone of the energy system in Europe, as Europe has declared its future to be climate neutral. Right? Today, we have about 197 gigawatt of wind installed in the EU 27 and the UK. But by 2030, we are expecting about 400 gigawatt. Right? So that's more than double of it, and particularly we need to ramp up in the offshore sector. If we extrapolate that and look at the ambitions that the European Commission put out there in the strategy plan, we see by 2050, and we are looking at a very big amount of power that we need. And offshore wind, it's taking quite a good portion of its time. So the quick question that we want to answer today during the session, it is, how do we go from 23 gigawatts that we have today to 450 gigawatts, right? And if we calculate that in the amount of time that we have here, we are looking at deploying almost 40 gigawatt of power per annum between 2030 and 2050. So a big challenge for us all here, but that is why we have ETIP, that is why we have the research community to develop here the innovation and necessary technologies to help our industry getting to what it needs to get, and to support the European Commission ambitions to become climate neutral from an energy perspective. When we look deeply into what we do at ETIPWind and to deliver this climate neutrality, we have defined our priorities for research and innovation. And we see here 5 pillars, right, of those priorities, all supported by cross topics such as digitalization, electrification, industrialization, and human resources. If we look at grid integration, here it is how do we integrate the current power, current wind power or renewable power in the power system, but at the same time we look forward and how do we design the future power systems and the future electricity system to accommodate the 100% or operate with 100% renewable, at the same time electrify as much as possible load, such that we are decarbonizing the system at 2 ends, not only generation but also consumption. Next generation technology, of course, this is and we are playing at the very edge here, playing with new materials, playing with designing and developing better and more performant turbines, and making the sector as sustainable as possible. Another example is floating wind here, and this is the next big thing for us as well, because floating wind will enable us to address opportunities in offshore sector beyond the shores where we have shallow waters. So it opens up the market to deep waters, to far away distances from the shores, but at the same time where they are very big wind resources. So in our work at ETIPWind, we basically take all this research and priorities, and we comprise them and document them in a so-called roadmap. And you see here an example of our latest publication on the research innovation priorities for 2020 to 2027. The structure is along the priorities. We have high, medium, and low priority topics, and then we have we are looking at the time frame that those priorities need to be in place. So we have short term, medium term, and long term. And then within here, then we have, and you recognize already the topics that I mentioned before, the pillars for our research and innovation topics. So I encourage all of you to look at the ETIPWind website, look at the roadmap, and get more familiar to it to see how we are defining the future of wind technologies in Europe. So that's an introductory word from my side about the ETIP. Today, as I said, we are in a workshop to address with a lot of industry experts about the how do we grow and how do we develop and scale up our industry to 450. But this workshop is just an opening of the overall online conference, right, organized jointly by ERA, SETWind, and ETIPWind, right? And to give you a bit more perspectives on this conference, I would like to invite my colleague Peter Eisen to introduce the program over the week to you, and then we'll take over and start the discussions planned for today. Peter, word is yours.
Thank you very much, Adrian, and welcome everybody in this online annual event. And we start this event with the ETIPWind workshop. The event is covering for 5 days, so from today until Friday, and we have an interesting program in order to get to know and to meet each other. And I was expecting the slides that Adrian was showing. So if you can please show the slides, that would be great. So the program for this week is very short, maybe you all know, but just to give a short head up. Every morning we have a half an hour opening session. Tomorrow it is me and Adrian talking about mainly ERA, Joint Program Wind, and the connection to ETIPWind. On Wednesday we have Adel El-Gamal, who is the chair of the ERA in total, talking about the ERA. And on Thursday, we have Helene Gray, who is the head of unit for the European Directorate 1, talking about the clean energy transition. And on Friday, we have Siemens Gamesa Renewable Energy, David Molenaar, who will talk about large turbines and some interesting concepts. Tomorrow, we also have the General Assembly, where we will talk about various R&I agendas, the impact of COVID and the Clean Energy Transition Partnership, followed by the SETWind workshop on creating multinational projects and lighthouse initiatives. And I think that is a very interesting one, where the country representatives meet with ERA and with ETIP in order to shape larger research programs for the next years. Then the workshops on Wednesday are with infrastructure for material and structural testing, headed by Paul McKeever and Arno Verwingerden. And we have transforming the energy system and impact to the European citizens with Nicolaus and Lena. And then on the Thursday, we have 2 sessions on the change in wind conditions and impact to the wind turbine design with Jake and Antonio. And later the afternoon, floating offshore wind technology with John Olaf Tande. And then there are 2 interesting workshops on Friday, simultaneously, one on open and fair data, and the other is on integrating priorities and sustainability, social acceptance and economics into R&I. So that's for the program. I invite you to join it. And then a small word on lighthouse initiatives. We are pushing the development of lighthouse initiatives within the European context for some time, together with SETWind and with ETIPWind. And we define 2 important topics. The one is enable a reliable power system operation with large-scale offshore wind, so system integration in a way. And the other is to make floating wind cost competitive, so all about floating wind power. And what we have seen is that in these topics are covered with the Green Deal calls that are almost launched. And these are demonstration projects. And demonstration projects, we know they benefit only a few companies. So we are really stressing that we should also make a larger lighthouse initiatives around these topics, aiming at the lower TRL research. And with this, I would give you the word back to Adrian, and I wish you a very nice long week with interesting discussions.
The entire week here. Let's go back to the program of today. So as we said, we were just passing by the introduction here together with Peter, and we are going to have a keynote presentation from IEA, and then 2 panel discussions, one on scaling up offshore wind development and the other one on providing stable and secure energy. And at the end of the day, again, conclusions on some discussions. So as you participate in the discussion, put your questions in there. The moderators will try to mingle your questions together with some questions that we have prepared for the moderation here. So without further ado, I'd like to give the word to our keynote speaker here, Ignacio Martí, who is the secretary at the IEA Wind Technology Cooperation Program. Ignacio.
Hi, thank you very much, Adrian, for the introduction, and thanks for the invitation to participate today as a keynote speaker in the workshop. So I hope you can see my presentation now, which you can. And my name is Ignacio Martí, and as has been mentioned, I'm Executive Secretary for the IEA Wind Technology Collaboration Program. I'm going to try to give you a global perspective on research and innovation related to this big challenge we have, 450 gigawatts offshore wind. So let's have a look from an IEA perspective. What can we do? What are we doing? What can we do to achieve that goal? The presentation will have several points. I will say a few words about IEA Wind for those of you that may be not so familiar with it. Then I will focus on research and innovation trends. More specifically, what is going on with investments, with research and innovation resources, but also how it is offshore related research and innovation moving and expanding from the traditional areas to the new areas, geographic areas. What are the future trends? And then I will end up with a call for collaboration that I start saying now. Collaboration is crucial. But let's have a few words about IEA Wind, the International Energy Agency group working with wind energy. So this is a collaborative initiative that involves at the moment 24 members in Europe, America, and Asia. And our members together represent 85% of the installed capacity. So it's a quite representative group related to wind energy. And of course, the important thing here I would like to stress is that we have a global perspective. Our members in Asia, in Europe, in America as well, define the agenda, discuss, bring challenges, bring lessons learned, etc. So when we present IEA Wind, when we talk about our findings, our activities, it is really a global perspective, which is a quite unique position for IEA Wind. I would like to invite you to have a look at our website, where you can find all our information is for free. There's plenty of information, reports, documents, recommended practices, information about coming activities, etc. So please have a look there. But one of the things also that makes IEA Wind so special, it is that we have been there, not me personally, but of course many other people have been there for more than 40 years. IEA Wind started in 1977. What you see there in the screen, it is small pictures of all the annual reports that have been published by IEA Wind since 1978. So we have really a long tradition there. You could say that the history of wind energy, it is somehow summarized in our reports. So it is a good way to see how things are evolving. And what I'm going to present today, it is the information, some of the information that it is in our latest report from 2019, our annual report. So let's have a look. Let's start with the strategic objectives, which are very relevant for the workshop today and the coming year and the coming days as well. We have 4 strategic objectives within IEA Wind. The first one, it is maximize the value of wind energy in energy systems and markets. The second is lower the cost of land-based and offshore wind energy. Then we have facilitate wind energy deployment through social support and environmental compatibility, so known technological issues. And finally, foster collaborative research and the exchange of best practice and data. And this is the DNA of what we do in IEA Wind. It is this collaborative research. So let's see in a little bit more detail. I don't expect you to read this, but this is just to show the range of activities. We call them research tasks, which are collaborative projects that are decided in between the member states from Asia, Europe, America. What is important? What is it that we can address? And there is a variety of activities that involve activities in, for example, forecasting, in systems engineering, social science, environmental effects, etc. So this agenda, it is defined by consensus with our members, and it is giving an indication of what are the challenges and what are the opportunities as well that we have in our community, in the wind energy community. But let me show you some information which is quite relevant today as well, and we capture through our network of members. Every year, we collect the R&D, research, development, and demonstration investments that every country is reporting year after year. And the question here, I mean, I have put together this graph here to show what is the trend and what is the situation from year 2010 to year 2019, to last year, right? So all this information is based on the reports we receive from our members. You can see on yellow, and the yellow color, it is the total number of countries participating in ETIPWind, the total expenditure in research, development, and demonstration. Then in blue, it is Europe, our European members. In orange, it is our Asian members, which is Japan, Korea, and China. And then in gray, it is our American members, which is the US, Mexico, and Canada. And there are some things I would like to highlight here. First of all, it is a big fluctuation on a yearly basis. This means that it is, you could say, it's a little bit unpredictable. How much are we going to have next year? It is a very difficult question. Many countries don't have a wind energy program, research and innovation program. What they report is just projects that they have funded on the previous year. And then there is another thing that I would like to mention. The overall trend is negative, meaning that slowly we are having less and less investments on, this is wind energy in general, not only offshore wind, it's all wind energy related research, development, and demonstration. So we need to watch for this trend, because we are losing some of the momentum that we had in the previous years. The only region that is growing is Asia. It's growing very slowly, but it's growing. And the region that is decreasing more quickly in terms of research, development, and demonstration funds is Europe. But there are some other trends I would like to mention as well. As you know, offshore wind has started mainly around the North Sea a number of years ago, with some countries developing activities there. But the trend is changing now. Let's say in the North Sea, of course, we still have activities, but there are some other countries, especially in the south of Europe, that also are getting involved in offshore research and innovation activities. All this information I'm going to present now, it is based on the reports we get from our members. So, for example, Denmark reported 4 new test sites for offshore wind turbines added in the last year. In Finland, a demonstration offshore wind farm has been reported as well. In Ireland, there is a new test site related to offshore wind activities as well. In the United Kingdom, they commissioned a blade erosion test rig recently as well. But France, look at this large amount of activities there. There are lots of demonstrators, as you know, many of them involving floating wind, meaning that there is a lot of activity both in the Atlantic coast, also in the Mediterranean coast. But also Spain, for example, is reporting 2 new test sites. And in Greece, there is a tension leg platform for different activities, including LiDAR system to support offshore wind. But the trend, it is also expanding east-west. So we have been reported a number of activities in the US with some demonstration projects and some integration activities that will facilitate, grid integration activities that will facilitate the integration of the energy that the offshore wind farms will produce. Of course, in the US now, they have all the development, the offshore wind development, and it is a connection with the demonstration, research, and innovation activities as well. And then, for example, another activity they reported is the upgrade of the blade test facility that they have. But what happens in the east? Korea has got a new accreditation in the IEC RE for a blade site for blades in the area of 7 megawatts as well, which will serve offshore purposes. And China recently reported that they tested successfully a very long blade as well for offshore wind primarily. So what are the trends that we see also in our activities? The new tasks that have started some time ago, recently, are on systems engineering, digitalization, life extension. Some highlights here: there has been a reference offshore wind turbine and produce in one of these tasks. Another one on the digitalization that will improve resource assessment, operation and maintenance activities. We have got a new task, a new project recently on life extension as well, which is telling us what is more important for our member states now. And coming soon, we have 2 new tasks on wind farm control. Flow farm control is called, to provide grid services and to exploit the potential, the full wind farm potential in terms of control and blade recycling. So what are the key trends? The key trends are system level, digitalization, and sustainability. And let me finish with just coming back to our strategic goals. The question, how to achieve 450 gigawatts offshore wind? Well, I would say our strategic goals are perfectly aligned with this challenge. If we continue reducing the cost of both land-based and offshore wind, and if we maximize the value of wind energy in the context of the energy system and the market, and if we do that, taking into account the social and environmental compatibility, all of that in the context of international collaboration, then I'm sure we will achieve that goal. And we will do that quickly because we don't have a lot of time. We know that we're under pressure for the climate goals and objectives. So we need to really work together. We need to have more initiatives that bring the knowledge, the know-how, and the transfer of experience together. So that was my presentation today. Thank you very much.
Thank you very much, Ignacio, for your input here. So without further ado, let's jump into the first panel, and that's scaling up offshore wind development. Javier, floor is yours.
Thank you, Andrea. So yes, let's have this first session. The idea is to see what is needed to scale up the technology and to be able to achieve this 450. So not to lose any time, I would like to introduce my three colleagues that will be with me just chatting around this topic. Andre is coming from Hitachi ABB Power Grids. I think it's quite new, this integration of companies. So he will be providing us the view of the integration of the wind farm. Aidan is coming from Siemens Gamesa. So yeah, wind turbines are always the core of any wind farm. So this is something we cannot avoid. We need to see what is going on. Hi, Aidan. And then we are also having Leif. Leif is going to tell us which are the challenges from a promoter side. Leif is the head of technology at offshore, so he is in charge of all these new technologies in floating. So hey, here we are. So I will first request my colleagues to introduce themselves to point wherever they feel they can point to us. Please be brief, 1 minute each if you can. Leif, do you want to start?
Good afternoon. My name is Leif Delp. I'm heading up floating offshore technology in Equinor. Previously, I was project director for Hywind Scotland, the world's first floating wind farm. I was also project manager for Hywind Demo, the world's first floating wind turbine back in 2009. So I've been working with floating offshore wind since 2006. And except from that, I have a lot of background on the oil and gas business.
Thank you, Leif. Andrea, do you want to step in?
Thank you, Javier. So good afternoon, everyone. My name is André Burdet. I'm working for Hitachi ABB Power Grid. It's a joint venture between Hitachi, majority shareholder, and ABB. So my responsibility in Hitachi ABB Power Grid is to look after the entire portfolio of one of our business units, the strategy on our portfolio and related investment and marketing for HVDC, FACT, substation, semiconductor, and of course from consulting to services of those systems.
And then finally, Aidan.
Yeah, hi, Aidan Cronin here, Siemens Gamesa. You can learn all about us on the web. I just like to use the time to say that at 450 we need that as a minimum to change the power sector and the industry as such. We need a huge energy resource, and wind is a huge energy resource. You could say if you look at what's happening in California now, that can be in Europe within 20 years. So I think we're joking if we don't do something. Then if you add floating to conventional, then you get 11 times the amount of resource. And then maybe as a last thing, since we're pressed, I think within 100 years, we'll have to have a lot more infrastructure that floats. So maybe the entire first kilometer of Shanghai will have to adapt to rising sea levels. So it'll have to be able to rise up and sink down again. So I think we are at the cusp of developing that technology also. There we are. Thank you.
Lovely, Aidan.
Yeah.
We need you as an ambassador.
Yeah.
Okay, so let me tell the people first which is going to be the dynamics. I will be chatting with my colleagues to introduce the main topics for discussion, but please feel free to forward questions. So the back office will be selecting them for me. So I'm concentrated on my colleagues, and we will try to make a space for questions coming from the audience as well. So Aidan, I would like to start with you. I mean, the wind turbine is the core of a wind farm, by far. And we have seen recently several announcements or very big machines that are in the 10 to 12 megawatt. And I know that there are some promoters that are starting to play with 15, 18, 20 megawatts machines that are not yet even designed. So which are the challenges for the new generation of wind turbines? Where is the limit? Which is the work you have to do?
Yeah, well, I think whenever we speak of limits, we get disappointed. Luckily, so far, very quickly. But I think there's of course, the main thing is whatever we develop has to drive down the cost. If it doesn't drive down the cost, then there's no business case. So I think that is the challenge, because you often get people to say, okay, we would like a 15 megawatt, but are they prepared to pay for 15 megawatts? And that's always the big discussion. And there's no doubt that optimization of materials, we're only as good as the next good idea. So we need to really work in tandem with our other colleagues in the industry, but also with academia and research institutes. So we get the flow through of new ideas, we get the new materials tested, we get the new control what you call systems tested. And another thing we need a stable, you could say, at least in Europe, stable European pipeline of projects. Because this stop-start, that does damage. We need to have a flow through, and everybody, not only us, but all the other manufacturers, all our sub-suppliers, etc. But then we get the economies of scale, and we keep the wheels turning. And there's no doubt about that also. I think they're the big, and I think also you also have to be cautious. As I said in the old, when you watch the old films, they had these lovely steam ships, and they had steady as she goes. And I think that is the main rule in offshore, that you will get less expensive offshore, but you'll never get cheap offshore. It will always surprise you. It is a very, very big resource, and it puts quite a loading on your machinery. But it also has the capacity to save a lot of the world.
Okay, thank you. Leif, we've been discussing in previous meetings, and obviously one of the things promoters are looking for are bigger and bigger projects. So which are the challenges you are facing? Which is the size you are looking for? And which are the fundamental problems you have to tackle?
I think from Equinor and a developer's perspective, first of all, as also mentioned by Adrian, we need a steady pipeline of floating offshore wind projects. And that has to be based on that we have predictable regulatory framework. We're also developing available areas. And that's back to the governments and the different countries to kind of establish that, and that shall be the basis. And we're moving from technology and pilots to commercialization and industrialization of huge projects. We're talking about 500 megawatt, 1 gigawatt size of projects. And for sure, to meet that ambition, we need to mobilize the supply chain, that's for sure. And the need for a substantial ramp up of their capacity within fabrication of the different part of a floating offshore wind project. That means the floater, dynamic cables, mooring systems. And we also see that we need available space to fabricate all these parts, especially the floaters, which is kind of very space consuming. We're talking about maybe between 5,000 and 10,000 square meters per floaters when you do the assembly. So these are really important part of the ramp up of the supply chain. That will also include port infrastructures and vessels. And in parallel, we are developing new technologies, optimizing the established technologies, and all these have to go hand in hand. But I think the main purpose now and main challenge we have now within the industry is to kind of industrialize the floating offshore wind industry, because we have seen what's been kind of development from bottom fix, and there should be no way that we should see the same for floating. It's more challenging, yes, but as mentioned also by Adrian, it's more windy areas where you can put this floating turbine. So that is the kind of view what we are really working hard to kind of have lower the LCOE. Thank you, Leif. This is opening questions for André and for Aidan again. So for André will be, hey, the size is going to be bigger, so probably connection to the ground is going to be to the mainland or to wherever you are connecting is going to be much more complex. Probably you will need to, let's say, connect to the mainland to different points at the same point in time. We've been talking about hybrid wind farms from a market perspective, but this is opening also a question about mesh configuration. So probably you can illustrate us on that.
Yeah, this is a great question, Ravi. If you look today at offshore wind, I would say like all projects are developed on what we call a point-to-point connection. So you have the offshore wind farm and then you connect it to the land. So it goes well today because the size, the input, the power feed from the offshore wind to the grid is relatively small. So the grid can actually cope to get the energy in and then distribute over land, over a country or a region. But if you think of the 450 gigawatt target that we have, it's going to be like more than 200 gigawatt in the North Sea, around 100 gigawatt or maybe a little bit less in the Baltics and Mediterranean and Atlantics and so on. So we're going to have literally hundreds of platforms connecting the offshore wind farms to the land. And then when you start to get at this level, the input to the grid will be so massive that you will need to start to actually utilize more power quality devices and also probably trade between countries. So this is where comes actually the idea of the mesh grid, saying that you cannot do hundreds of like point-to-point connection to the land, but actually connect the different offshore wind farms together in a mesh configuration and connecting to the different countries. So this is what we can see coming up. There are some first mover in the market moving with mesh grid configuration. We believe it's going to be at the industrial scale within the next 5 years, and probably within the next 5 to 10 years, actually a substantial element of the strategy going forward for offshore wind. The key enabling technologies for this, multi-terminal configuration. Multi-terminal configuration, we have already, this is where you can actually connect different DC lines together to an AC lines. So we see first project there in Shetland, for instance, but also in other parts of the world, in China, in India. This is also about DC breaker, because you need to be able to isolate any fault line with HVDC in a mesh grid configuration so that you don't have the full system blowing up, basically. So you need to have a DC breaker. This technology has been proven at full scale earlier this year with a 3 milliseconds shutdown actually for 350 kilovolt 20 kA. So the technology is proven, and then interoperability, of course, the ability of at the system level, not the valve level on HVDC, but at the system level to communicate between the various stations. So I think the technology is there, but obviously we are on a scale-up phase for mesh grid today.
Okay, thank you, André. And then, Aidan, just connecting with the supply chain discussion that Leif was introducing. I mean, when I joined this sector, I perceived the wind turbines being with the same cost target as the automotive, but with the serious production of aerospace. So very small volume, very high demanding targets on cost. And you were referring to cost as the main driver. But obviously, if the turbines are bigger, you are going to produce less number of turbines. How do you, let's say, which are the challenges for the supply chain on the wind turbine manufacturing side to be able to reach these cost targets?
Well, I mean, you could say there's the driver, of course, is bigger and bigger and bigger, at least for the moment. And the interesting thing about floating may actually cap that. So if we get a good floating technology, we may optimize the floater and just start shipping the same size, whatever size we decide on, because it's a big challenge is the balance of plant. So the bigger the machine you can get on your footprint, then everybody's happy about that. But if it's a floater, then you can concentrate on that. Again, it comes back. I think it's very important, but it's also important for sub-suppliers. There needs to be sufficient margin. So we can't get into a rat race. We need to work very, very closely. We need to work closely with our what they call our customers, and also with our sub-suppliers. I mean, the multi-terminal is a classic. We need that. So I think that yes, there will be bigger turbines, not as many, but there are also a lot bigger components. And again, that comes back to the challenge that our sub-suppliers have to be happy that if they invest in a new larger component or a die for that they'll get the money back. So and again, that rolls back again to having a proper pipeline. So you need a proper pipeline. So the pipeline, and that drives everything, a stable pipeline. And maybe a last thing I would also say is I go around beating the drum when I'm in Brussels and otherwhere, is that currently it can take up to 15 years to get a high voltage DC line approved. It takes 6 years for a pipeline. So if those lines are, if the electrical line's not put in, then we'll have to go power to gas. Otherwise, we won't be able to land it. So we need to wake up. And if you want to see how to do it, look at the Chinese. The Chinese, they just do, they learn, they blow up, they make mistakes, but they do it, and they develop at a rate that's 2 to 3 times faster than us. That I think we need to get back our sense of adventure. Maybe with the research institutes, say, okay, let's try this. Let's push the multi-terminal. We need it tomorrow, in years, and also maybe have some form of test facilities where we can see. Well, we've now worked it for six months, and nothing's happened. So boys, how about adopting it? So I think there's a lot of multivariate what they call it challenges, but there are some of them.
Okay, so Andrea, this is coming back to you. I mean, HVDC versus AC. I mean, which is going to be the winner configuration?
But there will be a place for everyone, for sure. But especially for electricity, as in terms of, I would say, an efficient and economically and also environmentally as an efficient way of transmitting energy from where it is produced to where it is consumed, because at the end it's going to be produced in terms of electricity and consumed in terms of electricity. So anything in between, there's an existing grid infrastructure and you just want to add a piece. If you take HVAC, it's actually a more, let's say, a simple system to install for lower type of power and shorter distances to the shore. So typically you're going to have HVAC connection for maybe up to few hundred megawatt connection and less than 50, 60, 70 kilometers from the land. Then it would make sense to go there. Once you go on bigger scale, for offshore wind farms and then or shorter or longer distances from the shore, then you will see the economics in favor of HVDC going forward. So HVDC also, what we used to say is that in HVDC you get a STATCOM for free. So what it really means is HVDC is not only making it economically more feasible when you have longer distances, it's also that you can actually better control the power quality in the grid due to the let's say, power electronics that you use. And also this is the only technology really enabling an efficient mesh grid configuration. So I think if we go to 450 gigawatts, certainly we're going to see a mix. There will be short, like a smaller type of offshore wind farms that is easy to connect point-to-point HVAC. And then for the big systems, obviously you'd like to switch to HVDC going forward.
Okay, so I have some questions coming from the audience. I will start just launching at you. The first one is for Aidan. I mean, the supply chain is something that is more or less interesting the people. And I don't know, the question is about what is required to achieve full industrialization. I mean, you were talking about the portfolio of projects, but is there anything beyond that?
But I think also, I mean, if you look at Europe now, we're in a unique position because we're driving a lot of the technology so we can standardize. And I mean, as soon as you standardize, then it means that wherever we go in the world, we can bring our technology, give the drawings, they press button A, and you just start spitting out. And you could say that is our really great hope with floating. If we can standardize floating, by heavens, then it can get incredibly cheap, and your amount of deployment can be incredibly big as well. So I think the standardization that we agree and we don't compromise on quality, and we stay as we are as the pinnacle. I mean, you can see that in foreign countries or foreign competitors, that they copy the European standards because, I mean, we're delivering high quality power plant, so nobody's interested in it and breaking down. And it's interesting to see some of our Because foreign customers, you open their nacelle and they're using European components. And I think we need to stay at that leading edge, you could say, also in terms of floating. But I think Leif also perhaps has some views on that, I'm sure.
Yeah, Leif, the question is much more focused on you and your experience. It says for floating wind, there are some practical engineering and logistical considerations, industrialization. With the pilot projects for floating wind that have been deployed, has there been any consideration of measuring performance with the same tools that we will use for floating resource assessment in the future? There needs to be greater confidence through warranty, investment, insurance, to assist reducing the recoil. We need confidence to grow at scale. I think we've been discussing also things that probably are beyond this question is wind turbines that will be specific for floating. I don't know. Can you elaborate with the question and your own personal view?
You're asking me?
Yeah.
Yes, sir, for sure. Thank you for a good question. I think to follow up on Adrian's comments on standardization, for sure the turbines has to be standardized. But we also see that today we're kind of utilizing bottom fixed turbines on floaters, and there are some challenges with respect to the forces you have on a floating wind turbine compared with the bottom fixed. So we see some constraints with respect to tower diameter and blade clearances. So maybe in the future you have to kind of also have turbines which is more adaptable to a floater and the motions you have in a floater. With respect to the question about the kind of how we validate the floating concepts, both the Hywind Demo and Hywind Scotland has been highly instrumented. So we are measuring all types of accelerations and movements and strains and forces in the floater. So in a way we have documented the technology as such. That's why we say that we don't need a new pilot for a new concept. We're able to design new concept and document them based on all the experiences we have on the oil and gas floaters and now the floating wind turbines. And we have the Cooper analysis, which are now kind of also validated by the testing of Hywind Scotland and Hywind Demo. So in a way, we don't think that the challenges and the risks are higher for a floater than the bottom fixed turbine concept.
And coming back to this topic we discussed in other forums about having a specific wind turbines for floating. I mean, is there room for that? Does it make sense at all?
I think you have to look into it because we see there are some constraints and challenges using a standard bottom fix. You end up with constraints with the blade tip clearance and the diameter of the tower. Because then we have looked into solutions to extend the nose of the turbine. Could you tilt the turbine 0.5 degree? So there are measures, but for sure the turbine manufacturers has to see there is a pipeline for floating project, and then they will develop a turbine which is kind of more suitable for a floater because you don't have the same conditions in the North Sea as you have in Asia with respect to both wind and waves. So they have to be kind of a different design of both a turbine and a floater. But the main principles for designing a turbine, the main principles for designing a floater, that will be the same. That's how I see it.
Thank you. I have a question from Iman. What level of recognition is there in the industry that value-based goals rather than purely LCOE-based goals will play in driving new resource development? So I guess what is beyond cost at the very end? This is the question. I don't know who wants to jump in.
I can maybe take that one. Very interesting question. LCOE first is obviously we would like that the market is fully structured on LCOE, which is a different beast than actually structuring the market on a pure CapEx type of for sure. So when we speak about standardization and other things, we need to make sure that standardization will actually bring the lowest LCOE as opposed to the lowest CapEx type of industry. So I think that's the first thing that where we need to be careful is to preserve innovation, to preserve systems as opposed to, I would say, components into the standardization aspect. So how do we standardize the way the system works as opposed to a component, how it works. So this is one consideration. But then if we go further, is of course when we talk about LCOE, it's the economics, but we need to put two other things into it. It's about, I would say, the security of supply and also the environment, probably to close kind of the triangle between the economics and the rest. So in terms of security of supply, I think it's all about also how do we make sure that the system can be available like 99.9% of the time. And then it's about, I mean, how do you organize the connection to the grid, and how do you make sure that your system that you use, even in case of failure to bring the electricity to the grid, will actually manage this failure locally and not affect the entire grid in order to not, let's say, hinder the consumer to get access to renewable energy. So it's really the security of supply and how system ensure security of supply and power quality. And then the other aspect is sustainability. So how do you ensure that the system you install, like the grid connection, if I take my case, for instance, will actually have the lowest footprint to our land, and also in terms of CO2 emission and so on. This is where actually the place of electricity is absolutely central into the value chain from generation to consumption, as opposed to take steps where you use other vectors of energy transfer, could be gases or other things, into which, of course, the overall system efficiency will drop. So those kind of considerations certainly will be welcome from the industry, certainly going forward.
Okay. So connecting to what you have said, Andre, there is a question coming from Ola that is more or less asking for a kind of a spine, a kind of a huge mesh coming from Portugal up to Finland of HVDC. So your view on that?
This is where we go to the concept that people knows in the industry knows as super grid, the super grid concept. So obviously, I mean, there are like, the issue actually with this concept is not so much whether you have technology at the station level. Like, for instance, you have multi-terminal technology or DC braking technology, which again are pillars to, I would say, super grid configuration, because you can isolate fault currents, you can connect different DC lines together. Those technology are, I would say, at the industrial scale, proven at large, at full scale into the lab. The issue also relates to other type of consideration in between the station, which is the connection, because you will need to have cables or overhead lines, perhaps in some cases, and this needs to have permitting. This needs to make sure that people agree to actually build new lines or to use existing lines. So I think the consideration toward the super grid really goes around, I mean, how do we want to organize our lands going forward, whether we use this or we use other type of technology.
Who will be the promoter or the owner of this asset? Because probably this will go beyond what Leaf will be doing within a wind farm, I guess. I have another question here that is connected to something Aidan was just launching as an idea. If we don't have access to the grid, we will have to go power to X. So are there any plans or possibilities for the deployment of offshore wind linked directly to hydrogen infrastructure? So probably here both Leif and Aidan can contribute.
Yeah, I mean, if I take it quickly, I mean, we're going to construct a pilot plant to make hydrogen in Denmark within the next 3 years, and that then basically is to see how we can integrate wind and the hydrogen. The one caveat I would say, hydrogen, when will it have a big impact in wind? Maybe 10 years time. So it's not going to be, we need to start it, we need to develop it, but it's not going to be a what do you call it, a super rocket initially. But you have to remember what's coming up on the side, and that's battery technology. And everybody's focused on the battery technology that's being delivered for electric vehicles, but that's not the type of battery technology we want. In electric vehicles, they're looking for the lightest, what do you call it, and what do you call it, cheapest, you could say. We're looking for maybe a heavier version. We take a lot of power and last a long time. And there's some very interesting technologies coming there. So I think there's going to be a fast run on the battery technology, which will help us quite a lot initially, and then the hydrogen will start to move in, and perhaps ammonia for shipping, etc. And I know Leif has a lot of a lot of ideas. Equinor has a lot of ideas on that. So.
Yeah, please, Leif.
Thank you, Edin. I support your reflections, and I think from Equinor perspective, we are also looking into hydrogen, both blue and green hydrogen. So there are also initiatives, but they are kind of more at the research stage. And I think maybe in the next 5 years you will see some more results. And in fact, last week our PM she announced that Norway will kind of really now focus on hydrogen and put a lot of research and technology development into hydrogen development. So I think that's coming, and also support again in ammonium as kind of replacing fuel for ships and seagoing traffic. So there's a lot of initiatives, but I think they are not at the same stage as offshore wind with respect to maturing technology and also industrialization. But there's a lot of research ongoing now, so I'm very positive.
Good. Well, I think we are just running out of time. We have hundreds of questions in the web, but I feel we are just running out of time. So I would like to make a wrap up. The first thing for me is that hey, no bottleneck have been identified by you. I mean, you see no problem at all. I mean, it's just a matter of deploying the market, having the portfolio there, and it seems there will be no limitation in terms of technology. And is for me, what I heard is that we need to make the next step. We need to let's say depart from the pilot phase and reach pre-commercial or commercial phases as soon as possible, because we have the technology there, we have the willingness of doing it, and we have probably the ambition that is very important. So probably what we need is let us do it. I mean, is this point. The mesh grid, I think, is a concept that we will have to talk about. I mean, we've been talking about hybrid markets as a hybrid concept for wind farms, but hey, you are right. I mean, if we are going to deliver 1 gigawatt of energy from one wind farm, this will be something that will unbalance the grid, and we need to see how to do it. Power to X is something that again is an alternative market for us. We have been always thinking in electrons, and probably we need to think also in other markets, and this will also help us in decarbonizing the economy. And so I don't know if you want to add something, but for me, the final wrap-up is no limitations. We want to start.
I'd like to add that the Power to X could commoditize wind power. So then you have a commodity. So you can fill a barge off Norway, and then it can be autonomous. You don't need any people on board. And then the barge, you can decide, is you going to send it to London, to Amsterdam, whatever, as long as your cost of that gas is equivalent. And maybe one very, very last thing for me is we have to watch the LCOE, because you see now a lot of the oil companies are getting battered, because it's not necessarily the cost now. The future cost is starting to get added in. How much damage will be done if we don't change? I think we have to think in another way.
Good point,
yeah.
So I would like to thank you all. Thank you so much for this very interesting and participative workshop. I would like also to thank the audience for the questions they have forwarded to us. I hope we had more time, but this is life, and we are bounded by time. So I would like to make the introduction to the next panel, that probably they will be taking the challenge of how to integrate all this energy into the system, which will be the final architecture that we have to have. And I will be handing it to Marie Berthelot, that is the head of renewables at EDF UK. So thank you, Marie. Just the floor is yours.
Thank you, Javier, for this introduction. So good afternoon, everyone, and thank you for joining us today. I'm very pleased to be invited by ETIPWind to share this panel discussion. So as Javier said, I'm Marie Berthelot. I'm the head of renewable in EDF Research and Development in UK, and I am managing the R&D activities for the EDF group on offshore wind. So the topic of the panel today is how research and innovation will contribute to provide stable and secure energy in a scenario of 450 gigawatts of offshore wind by 2050. So with this target in mind, offshore wind will play a major role in the European strategy for the decarbonization of electricity production. Indeed, according to the International Energy Agency, it could become the #1 source of power generation in Europe in 30 years. Of course, wind generation is totally dependent on wind and therefore by nature intermittent. So it is thus necessary, in order to ensure the system stability and security of supply, to develop innovation and new mechanisms to mitigate the effect of offshore wind variability. As a first step, it's important to identify and quantify the stability needs of the future power system, and then propose solutions for the integration of such an amount of offshore wind in the future electric system. That's why we are talking today about stability and security, but also of reliability, flexibility, and efficiency, keeping in mind that this renewable energy should remain cost competitive in the following years. So we see the future electric system as an integration of a mix of solutions for transferring wind power quickly, efficiently, and safely from the site of production to wherever it is needed. In this panel discussion, so we will be curious to understand how the solution and innovation, like for example, grid infrastructure, interconnection, storage system, power tweaks, ancillary service, will be part of the technical solution in a cost-effective way. But of course, optimizing the integration of this vast amount of variable renewable energy in a few decades will not only require, as we say, a new range of solution and technology, new technology for wind farm developer and system operators, but also a strong collaboration and coordination between European countries. So this will be key to optimize the integration of offshore wind in the future. And Europe needs a visionary approach to deploy such volume. Today, we will talk also about market design, and this could help to have a good visibility and confidence in volume. Regulation, how Europe should elaborate a regulatory framework for offshore wind and especially hybrid projects, special planning, and long-term planification. So today, to understand these challenges facing us for the next 30 years, I'm really lucky to be joined by 3 experts who will bring their view on this challenging topic. So let me introduce you to Catherine Dykes, who is working in DTU as the head of section loads and control. Good afternoon, Catherine.
Good afternoon.
Norela Constantinescu, working in ETSO-NSOE, so Manager of Research and Innovation, and member of the governing board of ETIPWind. Good afternoon, Norela.
Hello, everybody.
And Stavrola Pesta, working in Ørsted as the head of transformer and HV components.
Hello, everyone.
So thank you being with us today and for accepting to answer to your question. Maybe before starting, you can introduce yourself in 1 minute. Catherine, do you want to start?
Sure. Yeah. Thank you for having me today. This is great to be here. As you mentioned, Marie, I'm Catherine Dykes, and I'm a head of section at DTU Wind Energy. At DTU Wind Energy, we do research across the spectrum of wind energy science and engineering. My particular interests are on system design and optimization and techno-economic analysis, trying to look at how do new innovations impact individual wind turbines, plants, and then broader deployment. And this is becoming increasingly more interesting as we think about wind becoming a foundational technology within future energy systems, making up 30%, 50% or more of the supply.
Thank you, Catherine. Norela, do you want to continue?
So Norela Constantinescu from ENTSO-E, so the Association for Transmission System Operators for Electricity. I'm leading the research and innovation team in ENTSO-E. We are involved in the work related to the projects, so like a knowledge sharing platform. But we also ensure the link with the transmission system operators members who are actually driving different developments, including one related to HVDC, interoperability, and future development of offshore. Of course, I'm from research and innovation, but we work very closely with the what we call the system development division, which is producing actually the 10-year network development plan. So where we will have all these offshore projects seen from the infrastructure point of view.
Thank you, Norela. Stavrola, would you be the first?
Sure.
The next story.
Yes, my name is Stavroula Petra, and I'm heading the transformers and high voltage components area within Ørsted. We are part of electrical systems, and together with our colleagues in substations and wind turbines, we are basically responsible for transmission systems worldwide for the Ørsted portfolio, and that of course includes right now lots of focus in APAC markets and the United States along with Europe. So delighted to be here.
Thank you very much. So let's start our discussion. And my first question will be for you, Catherine. We are talking about 450 gigawatts of offshore wind. That represents a lot of wind farm. How do wind farms will affect each other? And can we continue to build one by one? Or do we need a systemic approach to optimize power production?
Yeah, no, that's a great question. So yeah, that 450 gigawatts, that's a 10-fold increase or more from where we are today. So that's a huge amount of wind. If all of that wind power were concentrated in a single, region, say the nearshore North Sea area, obviously there would be huge impacts from farms one to another. For decades, we've looked at the impact of wakes of upstream turbines, reducing the energy production of downstream turbines and individual plants. But more and more, especially for offshore, we're seeing the effects of whole farms on each other. So it's important as we look into future development of offshore wind that we really think about regional planning and continental planning so that we can really get the best from offshore wind to supply our energy needs for the whole continent. So, we need to firstly better understand the impacts of farms one to another. And at DTU Wind Energy and elsewhere, we're doing a lot of research to understand the flow of wind energy from the atmosphere down through and into plants and across plants from one to another to understand the physical phenomena so that we can better design plants to perform in the future. But we also need to think about, the placement of farms across the entire continent. So, the study from Wind Europe, done by BBG, which looked about, how do we place farms not just in the North Sea, but all across Europe to reach 450 gigawatts. I think this is really important going forward, and that will require innovation and not just in shallow water, but deep water, so that we can have floating solutions that are also cost effective, so that we can really realize the full potential of offshore wind energy for Europe.
Thank you. Thank you very much for your answer. Next question is for you, Norela. Integrating these large volumes of renewable power will have a significant impact on Europe's power grids. And according to you, what are the challenges and what innovation in network do we need?
So first of all, we have to think about the concept. So how we connect actually the offshore wind farms to the grid. And today with the around 22 gigawatt, the integration is made, of course, point to point and radial from offshore farm to the shore, or from a hub of offshore wind to the shore. But of course, if we go, as Catherine mentioned, to these huge capacities, I don't know, probably 100 gigawatt by 2030 and by 2050, 308, 450 gigawatt, we have to change the concept of connection. And we started already to see with some projects, like, for instance, Kriegers, this type of hybrid projects which are emerging, so ensuring both interconnection and also connection to the wind farm. But afterwards, we have to go towards multi-terminal, multi-vendor, and sometimes maybe multi-purpose, as the previous panel was saying before, type of connection. Furthermore, there is a whole development which has to take place around the grid and spatial planning, because of course we have our assets, but this has to be taken into account into a broader view, including especially the environment and maritime perspective. And of course, this needs a lot of construction and financial efforts. And everything has to be done while coping with the different time leads between the generation development and the infrastructure development. You have mentioned before, I think, Marie, the fact that we have the balancing and security issue. On one hand, of course, this is true, but on the other hand, the development of technologies such as HVDC can be part of the solution. So we need to actually place the innovation around HVDC grid, the interoperability required, and of course, afterwards, the integration of these grids into the hybrid AC/DC system with all the issues which raised there. And of course, we will need the seasonal storage. Then on the market and regulatory issue, of course, this has to be complemented, and maybe I will talk a little bit later on this aspect. What I would say that what we have to do actually now at the first stage, according to where we look in ENTSO-E, it's actually to ensure that we build up first this interoperability between models, between vendors, so to have the interoperability of the technical aspects and of the technologies as such in order to be able to integrate.
Thank you, Norela. So you talk about hybrid project, and we foresee more offshore wind hybrid project being built. And this wind farm will be connected to market in different countries with different voltage and frequency requirements. So how do we overcome this, and what are the benefits of this hybrid project? This is a question for you, Norela.
There, what we can do is to go more towards a kind of looking at cost reduction and innovation. So, for instance, the standardization of the voltage levels to shore for AC 220 kV, for DC 320 520 kV. Then for the market, what I can say that we have to look at the development of this type of projects from the market and system operation efficiency perspective, and of course to align with the policy objective. Therefore, we were actually investigating in ENTSO-E the concept, and unfortunately I cannot tell you more on this, the concept of offshore bidding zone, which might be actually a way forward to facilitate the efficient integration of offshore generation.
Thank you very much. So we are talking about electrification and decarbonization of Europe economy. But we saw that for some sectors, like for example shipping, electrification is not an option. So how can offshore wind through Power-to-X decarbonize this sector? What are the technical challenges and what is the most effective use of wind power? And this is a question for you, Catherine.
Okay, that's a big question and combines a lot of things that are well beyond my area of expertise. But I think a key thing is what does wind have to do in the future? We know what it has to do today, and largely for the last again couple of decades, that's been try to produce electrons as cheaply as possible. Have the minimum cost of energy. Going forward, the question is, what will wind have to do, in future systems? And I really like that we've started shifting the conversation from system integration to system transformation, and started talking about, an energy system transformation that's built on renewables, with wind being, a key contributor to that. And so that future system could take on many forms. So it could be very similar to the one today, where, as we get more and more wind and other variable renewables into the system, we need to have them provide a lot of value to that system, not just in terms of low cost of energy, but also providing energy when it's needed and providing services to the grid for reliability. In another future scenario where you have really, really cheap storage, lots of transmission build out, highly elastic demand, maybe wind just needs to provide cheap electrons, and we'll find ways to use them. And Power-to-X is a great example of that. Maybe all we need to do is provide really, really cheap electrons from wind energy, and we'll figure out ways to use those effectively, whether it's through electrification for transport or other industrial uses. So I think we've started a dialogue with other technology areas that this has really started happening, especially in the last year or so, about what research is needed in wind energy to be able to provide value in these other areas for being able to help support this whole new energy system that we've only started to think about what it could look like.
Thank you very much. My next question is for Stavroula. So considering these high wind penetration levels with a scenario of more than 400 gigawatts, what can operators do to firm power production? What measures to increase flexibility sources can they add to their offshore wind farm?
Sure. As a starting point, we cannot do much about the wind, and after all, it does define what can be produced. But of course, there are things that can and should be done to firm the production. One way to stabilize the production is basically overplanting. That means installing extra wind turbines to be able to produce up to the limits defined by the transmission assets, and the feed-in limits over longer periods of time. And of course, one should accept that we might have to put a cap on the production in certain situations, but that of course will be a trade-off, really. So continuously we have to look at this as a trade-off. Another thing that can be done is basically battery storage and Power-to-X, like for instance Power-to-Gas, as ways to load shift the production and peak save the production. So those could also be possible solutions in terms of firming the production. Now, with regards to flexibility of offshore wind, because I guess that's also a question, then actually we are at a good place, because offshore wind is a very flexible form of generation when we compare it to other types of generation. And that is because it can be ramped up and down very quickly, but it can also provide ancillary services, for instance, voltage control and response frequency. So we are in a good place with regards to flexibility, I think. Yeah.
Thank you very much. Next question for you, Stavrola. So what are the challenges to getting offshore power where it is needed the most, and how to best integrate into or overcome weak coastal grid infrastructure?
Sure. So basically, the availability of the necessary grid infrastructure where wind farms are needed the most is the main issue here. Grid expansion and reinforcement basically is a challenge because it naturally is a long process to develop and construct transmission systems. So basically, yes, availability of grid infrastructure is the main challenge. But nevertheless, there are again solutions that we can implement. We can use modern technologies such as virtual synchronous machines to provide virtual inertia and short circuit power. Another thing that we can do is to use the more conventional synchronous condensers. And there are more solutions, like, for instance, expand the capacity or rating of HVDC or VTG inverters in grid forming applications. And last but not least, we could consider hybrid solutions. So, for instance, combination of STATCOMs together with energy storage, because again, we can have virtual inertia and short circuit power. So these are all possible solutions, but I think they will only help us squeeze the offshore wind into the existing grid infrastructure. I think if we are to succeed with the ambition set out in the Paris Agreement for 2030 and 2050, this won't be enough. So basically, as also discussed in the previous panel, there it will be really necessary that we go for large-scale offshore HVDC networks because they will both help us connect the offshore wind, but they will also in general help us connect deeper into the onshore grids. So yeah, I hope I answered the question.
Thank you very much. We have a question from the audience about multi-purpose connection. So it's for you, Nohela. In multi-purpose connection, is ENTSO-E considering coupling offshore and hydrogen infrastructure?
Yeah, this is an interesting question. To be honest, what we do in this more innovative part of the system development, so the 10-year network development plan, so we are looking at the level of the countries for the moment. I will maybe, I don't know if I should name the country or not, but it's a country which has a lot of offshore wind. So they are in fact assessing, and they are putting together cost benefit analysis, so a kind of CBA of common development of the infrastructure for electricity connection with the wind farms, or the development of a hydrogen infrastructure which will connect to the wind farm and then transport it to where it's needed. And this, it's yet at the level of thinking of design, but we go forward with the modeling to see actually which will be the best options from the point of view of the CBA, which for the moment we look upon. So we started to think in that direction. Yeah.
Thank you very much. This is a question for you, Catherine. But of course, I will be very interested to have your view, Nohela and Stavrola, sorry, about this question. So we are talking a lot about technologies, and especially young technology that is floating wind in Europe, and we see that we expect a huge increase of floating wind in 2050. So my question is, from a power delivery perspective, what are the specific benefits or challenges of floating wind?
Yeah, great question. Thank you. And I'll definitely be interested to hear the other panelists' responses as well. So I think, you know, when you're talking about floating wind, you're obviously talking about deep water. And so in many places, that means much farther from shore. So in terms of, power offtake and delivery to where it's needed, that of course is a key distinction from fixed bottom, because typically floating wind, in many regions of Europe and the world, you're going to be much farther from shore than for fixed bottom applications. So that presents both challenges and opportunities. On the one hand, it's a challenge because then you're talking about longer transmission lines, and perhaps you have less of a concentration of farms nearby to leverage, common infrastructure. But it also perhaps presents an opportunity if we're talking about, kind of power to X and some of these other technologies that are coming down the line. Maybe we're thinking, not so much about trying to build out a transmission system to go everywhere, but what are the other ways we can use the power generated by the wind farms directly for whether it's shipping or other applications. So in my mind, floating wind is critical to realizing the future we want for offshore wind. And it's a great space to think about really innovative technology solutions.
Thank you, Catherine. Sevrola, Norela?
So
sorry, go ahead.
If I may add, I don't know, because of course, I worked before with the wind industry as such, but since the last 7 years, I'm with ENTSO-E, so more on the grid side. I think the floating wind, of course, is, as you mentioned, Catherine, so it's for the deep waters, and probably it will actually allow other countries or other regions than North Sea and Baltic Sea, which are the first runners, so the front runners in the offshore development, to actually to benefit from this technology. And here we are talking about the Atlantic coast and then the Mediterranean coast as well. From the point of view of the grid, the floating might be a little bit more flexible than onshore installation. So it might allow actually a more flexible location, taking into account the boundary condition we might have, and therefore may add a little bit more flexibility to the grid as such. However, I think from the technological point of view, so I'm talking with my mind from the time I was working with the wind industry, I think it needs a little bit more development from technology and innovation point of view than the existing developments offshore with the fixed turbines.
And I completely agree. I mean, we are also monitoring closely the trends around floating. But as Norela points, there's still things that need to be further developed, of course. And then some of the challenges and solutions with regards to connecting to grids will be the same with regards to between floating and a normal offshore. So we really need to focus on the grid infrastructure still.
Okay, thank you. I have a question from the audience about the hydropower in the Nordic countries and for storage. Is it a good start to use that? Maybe for you, Catherine, first?
Okay, can you repeat the question then? Because
sorry, the question is, what about hydropower in the Nordic countries for storage can be a good start?
Absolutely, yeah. So I was surprised you handed that question to me. That's it took a second. I'm not a grid integration person per se, but of course, the Nord Pool in the north of Europe benefits quite a bit in terms of balancing the variable wind energy generation from hydro. And you see that in other places. So where I come from in the US, in the western part of the US, there are significant hydro resources, and that's been a boon to wind energy development. I think, what we're seeing, though, is if we want to move to, and that's part of the reason that Denmark already gets nearly 50% of its energy supply from wind energy already today. But if we look to the future, we're going to be trying to reach those level of wind share in places where you don't have a lot of hydropower. And that's where it gets really interesting in terms of how can we create a stable system built on a backbone of variable renewables like wind.
Okay, thank you very much. I have a question about digitalization and artificial intelligence. What is your feeling about and your view about these two new methodology? How we should use them to deliver secure and stable energy in the future? So this is a question for all of you. Stavroula, maybe you want to start?
Yeah, maybe I can start. I mean, it is a huge new focus area when it comes to us as developers to look into more sophisticated control systems, digitalization, OT security, and of course we do that. We have the focus, and it comes with quite a bunch of challenges, compliance issues, and all kinds of other stuff that as developers we need to keep an eye on and invest time in understanding and so on. And at least, for instance, in the United States, that's by itself a huge area with NER compliance and so on. But also back in Europe, a huge focus area going forward. Quite a key part of executing our strategy for the years to come.
Marie, if I can add?
Yes, of course.
I don't know. Of course, this is a more broader question. So it's not only related to the offshore development, and of course, artificial intelligence and in general the application of the digital technologies in order to support what Stavroula was saying about the ensuring the system stability and so on. It's very important, and then automation, which comes with it. Of course, behind this, there are a lot of requirements regarding the architecture and the interoperability for markets, and afterwards, of course, for the IT infrastructure, as well as the data exchange between the different actors. So I'm thinking in our case of, for us, it will be TSO, DSO, but also in the future with, for instance, with the gas or with the hydrogen. So therefore, the data exchange standards are important in order to be able to arrive to develop first models which talk to each other, and afterwards to operate the systems in optimal way.
Catherine, thank you.
Yeah, sure. I think I'd just add, we have so much data when it comes to just a single wind turbine, let alone a farm, let alone the broader electricity or energy system. And so for me, I think the data side, one, it's really challenging because there's so much data, and how do we handle all of that and make it useful for us in terms of designing and operating the system? But two, what does that data give us in terms of information? If you talk about your typical wind plant SCADA system, that's a pretty poor reflection of the state of the affairs of the actual wind farm in terms of what are the loads, what's going on in terms of the nuances of the wind field that's flowing through the plant. And so how do we at one time, try to handle all this huge amount of data that we have at our fingertips, but also get more data and the right data to really provide us the information that we need to better design farms and better operate farms in the future.
Thank you very much for this, for your answer. Maybe one more question. We are talking about stability and security of the energy supply. So how security of supply will affect the future of wind energy?
I mean, as I I started talking about, if the grid infrastructure is not there, if all these huge steps in terms of ensuring there is a way to inject all this offshore wind energy that is being produced, if we don't take action to invest, we will not necessarily achieve security of supply and integration of renewables into the grid. So basically, they are interconnected. You see, if we have an ambition to go all in renewables, we have to invest in this.
Yeah, I would agree. I mean, I think that, what we all want to get to is, a green energy system in the future where, renewables are 80%, 100% of that system. And so how do we make sure that system is stable and has secure energy supply when it's needed, and also make that low cost? And wind can do so much already, and it can do more. And so there's, research and development and innovation to make it do more. But there's also a lot to be done working together with the other, energy sources and the entire system design. So things like power to X and storage and, all these different stability service technologies. There's a lot to be done collectively. And it's not going to be one single technology that brings the solutions. It's going to be a whole system solution.
Fully agree.
Thank you. And Lorela?
Well, it's what was mentioned before. So of course there is capacity with the wind development. Of course, the grid itself can also provide certain capabilities. So we talked about HVDC, but also FACTS and so on. So there are all these investments which has to be put in place in order to ensure the security of supply. I would like to mention one project in which we worked. So it's again around the North Sea. So this is for sure the place where the development is going to take place. It was closed on an H2020 project, where we look indeed at the integration of 100% renewables and all kinds of studies which were done in order to ensure this. And I don't know, I would mention, for instance, the grid forming capabilities of the devices. So.
Okay. Thank you very much, Catherine, Norela, and Stebrola for your answer and for your participation today. I think that we are quite on time and really happy to see the different challenges that we are facing and we will face in the next 30 years. And happy to see that we all agree on the coordination and collaboration between European countries to meet this challenge. So thank you very much once more.
Thank you.
Thank you.
Good afternoon.
Thank you very much.
Thank you all. So we are moving ahead with the agenda, and we'll just do a wrap up with our moderator. Marie, thanks a lot for moderating our all-female panel, and Javier coming back into the loop here with the all-male panel earlier than that. And so let's kick it off. Maybe, Javier, we start with you a bit. What were your key takeaways from the panel and the discussion that you have moderated there?
Probably the major takeaway for me was that people was not seeing any limitation. I mean, probably the sentence "learning by doing" is something that is defining what the industry is willing to do. They are willing to move away from when they are today, the pilot phase, and to enter into pre-commercial or commercial phase. Obviously, this will not be the final size. Probably the final size of a typical offshore fixed water or floating wind farm will be in the order of gigawatts. But people is willing to move away and to introduce technologies. On the technological side, no major surprise. I mean, the wind turbine appears to have no limit in terms of size, the same as the wind farm. Probably the major discovery for me is all this mesh grid connection, because we've been talking many times about hybrids in terms of multiplying markets for evacuating the energy, but which are the implications for this hybridity is going to be quite interesting. No dilemma between HVDC or HVAC is, I mean, there will be combination depending on each wind farm. There will be a solution. That's not the point. And probably the most stressing factor for the industry in the upcoming years is going to be the supply chain, both in the wind turbine, because they will be facing pressure because of volumes that will be reduced, components that will be bigger, but also in the balance of plant. I mean, structures, cables, all these will require to have a supply chain in place that will be able to deliver quantity enough to build up these big wind farms. These are in a summary, this is what I took away from our discussion.
Marie, on your side?
So we discussed a lot about the different solution on the technical side. So we discussed about the grid infrastructure and architecture, and helping the integration of such an amount of offshore winds. We talk about, of course, the offshore and onshore grid and the reinforcement of interconnection. We talk about hybrid projects and the framework related to this type of project with the connection to more than one country. We talk about how we can facilitate the integration by using different type of technology like inertia. And we are talking a lot, as Javier says, we are talking a lot about storage and power 2x. So I think that, and it was said during the discussion, this is a combination of solution, of innovation. And this is also, there is also a strong need to collaboration in Europe. Really important to have a framework that is agreed by the different European countries. And it will help, of course, on the planification of the different the future offshore wind farm, but it will also help on the regulation. So I think that it's time today to have this, to build this coordination with Europe to address this challenge of 450 gigawatts in 2050.
Right. Thank you for your summary and summary inputs here. Listening up to the discussion here, right? I picked up a few points where I think the discussion could have go a bit deeper, and let us, maybe the three of us, explore more, because you are not just chairing the sessions here, but you are also experts in the wind energy and also in the integration of wind energy into the grids and the power systems. So one interesting point that caught my attention during the discussion was investments. I think it's rather clear how the promoters will do the investments for the wind itself, right, and develop the projects. However, it was not clear how do we do the investments for the infrastructure needed to evacuate that wind in one country or multiple countries at once, right? And any opinions, right, from your own perspectives, your company's perspective behind what could be a good arrangement here?
That's a really good question. So it depends on the country where you are. Depending on if you are in France or in UK or in Germany, Spain, etc. The investment, of course, will be key to optimize the integration of offshore wind. And the investment, I mean, in the grid infrastructure will be key. And as I said, it's really the investment is not the rule of Europe, but this is the rule of Europe to deliver a strong plan of investment in the future for infrastructure and network.
Javier?
Yeah, I think I agree with Marie. Depending on the country, the split between utilities or TSOs and DSOs, just to simplify the discussion, is complex. But I think the backbone is in hands of the member states. And here the challenge is how we encompass the grid development that is more or less driven by the demand and the generation coupling, how these plants are set up, how these investments that more or less are coming from the states are planned as well, and how they accommodate the planning that are in the national energy and climate plans. Because I think once you have the signal of the market, once the tenders are coming and the connection points are there, I mean, the investment that will be required for, I don't know, the connection coming from the wind farms will not be a problem. I think here we are talking much more about the core of the system, and this is the difficulty we are facing.
Yeah. I think this core of the system, right? One can just say we put all the cash in, and we agree at the European Union, right? And the European Commission agrees with the member states how to do that. All cash in, let's develop it according to whatever vision we think it is. Or we say we take a more pragmatic case and look at where the priorities are high, what's the business case for every investment, and then going about a bit on that cost-benefit analysis, like Norella was pointing out before, and try to see how that will work out, right? A little bit or slightly more complex, but could ensure a bit more success for everybody on shorter time, right? And here again, another point which I want to bring up in the discussion that, in my opinion, we could have explored a bit more, it is market setup. Right? How do we set up a market across Europe where you get enough visibility, what kind of revenues you can make, exporting power in different or to different customers, right? Today we have a lot of markets. We have the main market, Make Europe energy market, but there are a lot of PPAs, right? Power purchase agreements signed between producer and consumers, bypassing the entire system, right? That exists out there, but you agree on a price. And if that is favorable to the two of them, then the system in between just needs to transport it there. But I think we will need to move from this, ad hoc or here and there kind of arrangements to something more holistic that helps us, right, getting the benefits back from the investment we will do in the infrastructure. Any thoughts or ideas on the potential or a future market design on how that will either accelerate or try to not make as complex as it looks like the development of the future infrastructure in Europe?
For me, this is probably the hardest point of this discussion. I mean, and it's not about putting money; it's about having a single market. It's having the same rules for connecting whenever you are in France or in Denmark, because probably you can have a wind farm that is, let's say, dropping the energy in one market or the other, or how you connect to your consumers. And at the very end, the question is how you set up the rules for the cost recognition of these investments. And it's quite difficult because if you consider which is the business case for a road, just a road, probably is very difficult to do it. But if you don't put the road, the economy of the region will not evolve. And then once you have the road, probably you can make the numbers, which is the amount of people that is traveling through this road and which are the economies that are moved. But at the very beginning, someone was putting the money just because, hey, we need to develop that region. And I think if we are just putting under a business case some of the investments, this will not work.
Mm-hmm. Mm-hmm. Marie, any reflections on that?
So I think that market design is important to have a good visibility and confidence in the future for investor. So of course, the way it works today is maybe not the best way to have the return of investment, but it seems that we have to think of, as Javier said, of a broader system, and think of the different countries that are involved in this system. So it's really important to have a how can I say, a revenue stabilization mechanism, and this is very crucial for de-risking the financing of offshore wind projects. As I said, it will help to provide confidence for investor and a good visibility, sorry, of future.
Let's explore this further with one thought that came up during your answers here. We are in a mixed environment here between regulated and unregulated players, right? Each of them, and particularly unregulated players, driven by their own speed, right, to get revenues. While the regulated players, they are more guided on what they are allowed to do and not allowed to do. How do you see that, firstly, the speed of the two kind of market participants here, and whether would help, yes or no, if we would have only one side of the coin, either regulated or non-regulated entities participating in this build-up?
Marie?
This is a good question, and to be honest, I'm not the expert to answer this type of question. I will leave the floor to Javier.
No, I think it's difficult because, as you said, these are regulated and not regulated. So the challenge here is how you couple the speed of both developments. The problem for us is that we are not controlling one side. So this is depending on some other developments, some other markets that have to benefit from this big grid. But that was quite an interesting point in our session, that one of the panelists was saying, hey, let us start. If the grid is not there, we will produce gas. So I don't know what is, to answer your question, I don't know what will be first, or if we have to wait until both sides are at the same speed. But I think it's right that we have to move away from the status we have today, this continuous piloting of projects, especially in floating, and we need to go big. That's all. I mean, I don't mind what will be first, the hen or the egg. We have to.
Now, good, but that brings me to the last topic I wanted to circulate it with you, which was the hydrogen, right, or the gas, as you mentioned, Javier. So that also, it seems like, you know, everybody's tampering with it, trying to learn. Is it useful? Is it not? What can we do? It's only seasonal storage. It can be more than that. It could be actually a source of revenues for the developers when the grid is not there, or simply a source of revenues with or without grid. Seems to be quite some potential, or at least ideas behind, right? But at the same time, we all know, or the engineers in this audience know, with more, you know, conversion stages you put in between your pure source of energy and your consumption node, you more increase the costs, increase complexity, and therefore everything will be reflected on the cost of energy that is out there, right? So if we now take the glasses of our wind community here, right, we were in the last 2 decades, right, trying and innovating wind to bring it at a cost competitive resource, right, and we are now in a path of accelerating it up to the scale we wanted. So now in this, you know, let's call it takeoff, if we bring a mixture like with another technology that will potentially drag us slightly low or back in terms of the cost that we will produce, the technologies that we need to work with and so on. I don't know how you guys see that, but for me it's like, yes, could have its place in the overall energy mix, could have its place in providing the functionality that was discussed in both panels that we all need, flexibility of power here and there. But my concern really, it is what will be the cost that we as citizens of Europe will need to bear by introducing, you know, two parallel carriers, or too many technologies, too much complexity in our thinking of how the future looks like. Any of you to start with?
We talk a lot about hydrogen during the panel discussion, both panel discussion, and we thought hydrogen like a solution for the integration of offshore wind, for storage, for flexibility. And this is one point that EDF is supportive of, because we launched a new subsidiary called Dynamics to produce and to market low carbon hydrogen. We think that it's really important for offshore wind environment to be supported by this type of new technology. And as we say, of course, we are looking at a mix of solution, a mix of innovation, and hydrogen will be part of the solution and the innovation, according to us. Concerning the cost, of course, we introduce more complexity, but this is for us a challenge to use this innovation to help to reduce the cost of bulk. I mean the coupling between offshore and storage.
Thanks, Javier. Being mind of time that we will need to close this rather soon. Thank
That's
you.
a personal opinion based on that I was playing with hydrogen and wind 20 years ago. I think in the short term, the storage is not going to work, because unless you have let's say a curtailment that is an opportunity that you are losing, and there is a specific business case, but you are losing 50% of the energy in the process, going forward and backwards. But I think there are markets in which hydrogen, because of the intensity of energy, the density of energy you can have, are quite attractive. And this is especially important when you are talking about ships, probably aircrafts. And there is another sector that will be quite interested if we can provide them green hydrogen, that is the metal industry or this kind of economies. So just one way, from electricity, from power to hydrogen, and I think there are markets attractive enough for them.
Yeah. Excellent. Good. Well, again, thank you both, right, for helping structuring and helping driving this conversation here. I hope the audience got enough insights, right, about the technologies in the wind, technologies that we need to develop for wind integration power system, but also how do we want to design our future energy system in Europe. Thank you both. And just before closing, let me say that also from my side, what I see here, right, it is wind is ready to continue, wind is ready to scale up, right? We need to make sure the grid infrastructure is there so that we can put as much as possible electricity in the power system, electrify the system, and therefore decarbonize it as much as possible. And beyond that, investigate and scout new technologies such as hydrogen to help us decarbonize further beyond electricity. In all this, it's a complex ecosystem. We will need to collaborate. We will need to work together, being in the supply chain, one, inside the wind industry, but also beyond that. Also among the partners or among the stakeholders in the entire ecosystem, with wind, with grid, with the energy markets design, and so forth. So, and the last point here I observed today is that we had a very great audience. So thanks a lot for your questions, for your interest and participation being here today. Those questions that we were not able to answer in the sessions, we will get back to you in writing, unless they are not anonymous, put in the chat box. So thanks again from my side. Take care. We'll see you tomorrow in other sessions. Bye-bye.